Before we begin, find yourself somewhere comfortable. Let the room grow a little quieter around you. This is a story told at the pace of starlight, meant for those late hours when the mind is ready to wander gently without urgency. There is nothing you need to solve tonight, nothing to prepare for, just a question drifting through the dark and the steady ground beneath you. Imagine for a moment waking up to a message that feels too specific to ignore. Not a vague rumor about distant futures, but a precise claim, a date, a time, 7 seconds. The world, it says, will lose gravity. Not forever, just long enough for everything unbolted to lift from the earth, cars rising from highways, oceans peeling away from their basins, children floating upward in startled silence. And then, just as suddenly, gravity will return and the world will fall back down. The story carried a name that sounded almost reassuring. Project Anchor, a secret program supposedly funded with billions, quietly preparing for the event while the rest of humanity remained unaware. The details were careful, almost meticulous. A specific afternoon in August, a universal timestamp, a probability percentage, offered with decimal precision. It felt researched, it felt official, it felt to some frighteningly plausible, and yet from the very beginning it was only a story. The rumour first appeared in the way so many modern myths do, through a short video, overlaid text, and a voice that did not need to shout to be heard. The claim spread softly but quickly, slipping from one platform to another. Each share carried the same elements: a countdown, a budget figure, the suggestion of classified documents, the implication that governments knew more than they were saying. The original account disappeared not long after, and for some, that disappearance became proof. If it was false, why remove it? If it was true, perhaps someone had silenced it. It is easy to underestimate how powerful a specific date can be. August 12th, 2026. There is something almost comforting about a clear horizon line. In a world filled with slow, shapeless anxieties, a single afternoon marked on a calendar feels tangible. You can picture it. You can imagine where you might be standing when the clock strikes that hour. Fear, when it's given structure, can begin to feel manageable. But beneath the fear is something deeper and quieter. The idea of gravity vanishing touches a place in the mind that rarely gets disturbed. Gravity is not something we think about. It is simply there. The quiet weight in your limbs, the pressure of your body against the mattress, the way your breath settles into your chest. To suggest that gravity could blink off, even for a moment, is to suggest that the most fundamental layer of reality is unstable, that the floor beneath us is not guaranteed. And that is a powerful narrative hook. The rumour gained traction in part because it borrowed from something real. On that same August day, a total solar eclipse will cross parts of the world. Eclipses have always stirred something ancient in us. The dimming of the sun, even when predicted centuries in advance, carries a whisper of the uncanny. Shadows sharpen, temperatures drop, birds fall silent. For a few minutes, the ordinary rules of daylight bend. By anchoring the claim of vanishing gravity to an actual celestial event, the story gained a foothold in reality. The eclipse is real, the timing is real, the sky will indeed grow dark for a while, and when one part of a story is verifiably true, it becomes easier for the mind to let the rest pass without resistance. The numbers helped too. $89 billion, 1433 universal time, 94.7% probability. Precision creates an illusion of credibility. The human brain is comforted by decimals. They feel like the product of equations, of careful measurement, of experts leaning over glowing screens. But specificity is easy to fabricate. A number can be invented in an instant, and once repeated often enough, it begins to sound as though it must have come from somewhere. What made this rumour spread was not just fear, it was familiarity. We live in a time when institutions are questioned, sometimes rightly so. Governments have concealed truths before, corporations have misled, scientists, like all humans, have erred. This history of imperfection creates fertile ground for stories of secret projects and hidden knowledge. The suggestion that authorities might withhold information for our own good fits neatly into existing doubts. The story of Project Anchor offered a simple framework. There is a threat, there are people who know about it, and there is a reason you have not been told. That structure is compelling. It transforms diffuse anxiety into a narrative with characters and motives. It gives the mind something to hold on to, and perhaps most importantly, it offers a strange kind of belonging. To believe in a hidden truth is to feel briefly set apart from the crowd. You're among those who know. You have seen behind the curtain. In a world saturated with information, secret knowledge feels rare and valuable. But if you listen closely, beneath the dramatic imagery of floating cities and rising oceans, there is a quieter question waiting to be asked. Not whether gravity will disappear. It will not. But why such a claim felt powerful enough to echo across millions of screens? Why does the idea of the ground slipping away resonate so deeply? Part of the answer lies in our relationship with stability. Gravity is invisible, yet it governs everything. It holds the oceans in their basins. It keeps the atmosphere wrapped gently around the planet. It binds Earth to the Sun in a patient orbit that has endured for billions of years. We rely on it without noticing. We build our homes, our bridges, our entire civilizations on the assumption that down will always be down. When someone suggests that this foundational certainty might falter, even briefly, it brushes against an ancient vulnerability. We are creatures who evolved under open skies, attuned to shifts in weather and landscape. A sudden change in the rules of nature would have meant danger. That instinct lingers. And yet, there is also something almost poetic about imagining the world lifted for a moment into silence. Cars suspended mid-air, oceans forming vast shimmering spheres, a pause in the ordinary. The mind drifts there not only in fear but in wonder. What would it look like? How would it feel? It is okay to let the imagination wander through those images softly without believing them. Stories are powerful precisely because they allow us to explore impossibilities safely. They let us examine our fears without living them. As the rumour of Project Anchor spread, it met resistance from scientists, educators, and careful thinkers who explained calmly that gravity does not work that way, that it cannot simply switch off, that the mechanisms described in the viral posts misunderstood the very nature of space-time, but for some, the corrections mattered less than the narrative itself. When a story fits an emotional need, it can become resilient against facts. And so we find ourselves here, not to mock the rumour, and not to dismiss those who felt unsettled by it, but to examine it with patience, to trace its shape, to understand why it sounded plausible, and what it reveals about our relationship with science, with trust, and with the quiet forces that hold our world together. Tonight, we will move slowly. We will not rush to conclusions. The eclipse will come in its appointed hour, and gravity will remain exactly as it has always been. There is no countdown to fear, only an opportunity to look more closely at the architecture of a modern myth. In the next part of our journey, we will gently take apart the structure of Project Anchor itself. We will see how such stories are built, what they borrow from reality, and why they are designed to resist contradiction. For now, let the weight of the Earth rest beneath you, steady and patient, as it has for ages beyond counting. The weight of the Earth is still beneath you, the oceans have not lifted, the sky has not loosened its hold, and the quiet pressure of gravity continues its patient work. And now, with that steadiness in mind, we can turn our attention to the structure of the story itself, the architecture of Project Anchor, the way it was built piece by piece to feel solid even when it was made of air. Every enduring conspiracy has a kind of design to it. Not an accidental arrangement of fears, but a careful layering of familiar materials. Project Anchor did not appear as a vague whisper. It arrived with scaffolding. A program name that sounded official, a budget large enough to feel serious but not impossible, a precise timestamp, a probability measured to 0.1%. Each element placed deliberately, like stones in a wall. Consider the name again, Anchor. Anchors hold ships steady against currents. They prevent drift in restless water. To suggest that a government agency would name a secret program Project Anchor is almost poetic. It implies stability in the face of instability, control amid chaos. The name alone does half the emotional work before any numbers are introduced. Then come the numbers, $89 billion, not an even 100. Not a vague, massive funding. A specific figure that feels drawn from a ledger. 1433 Coordinated Universal Time, a timestamp that sounds as though it was copied from an official memo. 94.7% probability. The decimal is the most powerful part. It whispers calculation, spreadsheets, simulations running deep into the night. Specificity is persuasive because it mimics the language of real institutions. Governments speak in budgets and deadlines. Scientists speak in probabilities and margins of error. By borrowing these rhythms, the story dressed itself in the clothing of legitimacy. But real institutions, for all their flaws, leave traces. Paper trails, digital footprints, people who talk. Programs of that scale ripple outward. Contractors are hired, committees formed, budgets debated. Money that large moves through systems like a stone dropped into water, creating rings that spread far beyond their source. Project Anchor, by contrast, left no rings, no documents, no scanned memos with letterheads and signatures, no journalists staking their reputations on leaked material. Only text on screens, repeated and shared, untethered to any artifact that could be examined. And here is where the design becomes more subtle. A well-built conspiracy anticipates objection. If you ask, where are the documents? The answer is ready. They were destroyed. If you wonder why no official acknowledges the program, the response is immediate. Of course they deny it. That is part of the cover-up. Every absence becomes confirmation. Silence becomes evidence. Denial becomes proof. This is what makes such narratives resilient. They are self-sealing. They turn every counter-argument into reinforcement. It is like trying to grasp water. The harder you squeeze, the more it slips through your fingers. There is another feature worth noticing, the inclusion of a vanished expert, an unnamed physicist whose paper was retracted, who allegedly disappeared after revealing too much. The detail is vague enough to resist verification, yet concrete enough to stir unease. It suggests authority without accountability, expertise without identity. In reality, the world of science is messy but traceable. Papers are published with names attached. Retractions are public. Researchers have histories, affiliations, colleagues. Knowledge accumulates in layers, and those layers are visible to anyone patient enough to look. But the conspiracy did not offer layers. It offered shadows. Why do such shadows attract us? Part of the answer lies in our complicated relationship with power. We know that institutions are not infallible. History contains genuine secrets, genuine deceptions. That memory lingers like a faint bruise. When a story suggests that officials are withholding information to prevent panic, it echoes past events where information was indeed delayed or concealed. The difference, though, lies in scale and plausibility. Hiding a single incident is one thing. Concealing a global, planet-altering event for years, while coordinating thousands of scientists, engineers, and administrators, is another entirely. Large systems are noisy, people disagree, whistleblowers emerge. Secrets of modest size are difficult to keep. Secrets of planetary scale would be nearly impossible, and yet, impossibility can feel less important than emotional resonance. Project Anchor did something psychologically elegant. It provided a villain that was familiar but not monstrous. NASA, a name associated with rockets and telescopes and quiet laboratories, became the keeper of hidden knowledge. Not evil, perhaps, but paternalistic, protecting the public from truth. That framing allowed believers to feel both skeptical and reasonable. They were not rejecting science, they were questioning its messengers. The story also positioned its audience as insiders. If you had seen the video, if you had read the post, you were part of a smaller circle. You had access to information others dismissed. That feeling of inclusion is powerful. In an age of overwhelming data, curated secrets feel intimate. Notice too how the timeline was chosen. Not tomorrow, when falsification would be immediate. Not decades away, when urgency would fade. Roughly a year and a half into the future, a horizon close enough to imagine, distant enough to linger. The mind could circle the date repeatedly, rehearsing possibilities, marking it quietly on mental calendars. This is architecture designed for attention. And yet, beneath the careful design, the foundation remains fragile. There were no verifiable sources, no corroborating evidence, no independent confirmations. The entire structure rested on repetition and emotional plausibility rather than material proof. It is important to say this gently. Believing such a story does not mean someone is foolish. It means the story was constructed skillfully enough to align with existing doubts and curiosities. It met people where they already stood, between trust and suspicion, between fascination and fear. If you find yourself remembering the first time you heard it, perhaps feeling a flicker of uncertainty, that is natural. The human brain is wired to attend to threats, especially ones framed as sudden and catastrophic. 7 seconds of gravity loss is dramatic enough to bypass analytical filters and land directly in the imagination. But analysis is a form of patience. When we slow down, when we examine each beam and joint of the structure, the design becomes visible. The official sounding name, the fabricated budget, the decimal probability, the unnamed expert, the preemptive dismissal of all counter-evidence. Each piece reveals not a hidden truth about physics, but a familiar pattern in storytelling. Water can look deep in the dark even when it is shallow. Stone can feel solid even when it is hollow. As we sit with this, notice how the urgency begins to soften. The date on the calendar loses its edge. The eclipse remains what it always was, an alignment of celestial bodies, predictable and beautiful. The rumour begins to resemble what it truly is, a modern myth, crafted with digital tools instead of ancient firelight. And myths, while powerful, are not immovable. In our next chapter, we will turn from the architecture of rumour to the architecture of the universe itself. We will look at gravity, not as a switch to be flipped, but as a patient curvature woven into the fabric of space-time. We will move from the shadowed design of a conspiracy into the quiet elegance of real physics. For now, let the idea of hidden bunkers and secret budgets drift away like mist over water. The ground beneath you remains steady. The stone of the earth has not shifted, and the force that holds oceans in their basins has been working, without interruption, for billions of years. The imagined bunkers and vanished documents have faded now, like footprints in sand washed gently by the tide. We have examined the architecture of the rumour, we have traced its beams and hollow supports. And with that structure set aside, we can turn our attention to something far older and far more enduring than any digital myth: gravity. It is so constant that it becomes invisible to us. You do not wake in the morning and marvel that your body remains resting on the bed. You do not step outside and pause in gratitude that the air has not drifted away into the dark. Gravity is the quiet companion of every breath, the patient hand beneath every step. It asks for no acknowledgement, and so we rarely offer one. And yet, if someone suggests it might vanish for 7 seconds, the suggestion feels unsettling precisely because gravity has never once betrayed us. To understand why it cannot simply switch off, we must first understand what it is, not as a word, but as a reality. Centuries ago, Isaac Newton gave us a language for gravity that felt both simple and profound. He proposed that every object with mass attracts every other object with mass. The strength of that attraction depends on how massive the objects are and how far apart they sit. Double the mass, and the pull doubles. Double the distance, and the pull weakens dramatically. It was a formula that could predict the fall of an apple and the orbit of the moon with the same quiet confidence. Newton's description was extraordinary because it worked. It allowed humanity to chart the heavens with remarkable precision. It allowed ships to navigate oceans guided by predictable stars. It eventually allowed rockets to leave Earth and arc gracefully toward the moon. For more than 200 years, this understanding of gravity felt complete. But Newton himself admitted something curious. He could describe how gravity behaved. He could measure its strength. He could write equations that sang with predictive power. Yet he could not explain what gravity truly was. How does the sun reach across millions of miles of empty space and pull the Earth into orbit? How does Earth hold the moon in its steady dance? The mechanism remained mysterious, like a hidden current beneath calm water. Then, in the early 20th century, Albert Einstein offered a different vision, one that reshaped the way we imagine the universe. Einstein proposed that gravity is not a force in the conventional sense at all. It is not an invisible rope tugging objects together. Instead, it is a property of space and time themselves. Space and time, he suggested, are woven together into a single fabric, space-time, and that fabric bends and curves in the presence of mass and energy. If this sounds abstract, that is because it is. But we can approach it gently. Imagine a wide, stretched sheet of rubber. Place a heavy stone in its center. The sheet dips beneath the weight, creating a curved depression. Now roll a small marble across the surface. The marble does not move toward the stone because the stone is pulling it with a hidden hand. The marble curves inward because the surface itself is no longer flat. It follows the shape of the sheet. In Einstein's view, the sun is the heavy stone. It bends the fabric of space-time around it. Earth is the marble, following the curved geometry created by that bend. What we experience as gravity is simply objects moving along the straightest possible path through a curved landscape. This means something subtle and profound. Gravity is not a switch that can be flipped on or off. It is not generated by a machine that might malfunction. It is the shape of reality in the presence of mass. As long as Earth exists, with its iron core, its mantle of stone, its oceans and mountains and atmosphere, the space-time around it will remain curved. And as long as space-time is curved, objects near Earth will follow those curves. For gravity to disappear, Earth's mass would need to vanish. Not rearrange, not flicker, vanish entirely. 6 trillion kilograms of rock and metal and water would have to cease to exist in an instant. And even then, the story would not end, because mass cannot simply dissolve into nothingness. It can transform into energy, yes, but energy itself bends space-time. It, too, carries gravitational influence. There is no mechanism within known physics that allows mass to wink out of existence without consequence. Stars explode, but their material scatters into glowing clouds. Black holes form, but they retain the mass of the stars that collapsed into them. Matter shifts form. It does not evaporate into absence. This is why the idea of gravity switching off feels so alien to physics. In Newton's framework, it would require all mass to stop exerting attraction. In Einstein's framework, it would require space-time itself to flatten instantly despite the continued presence of mass. Both scenarios contradict the foundations of our understanding, and this understanding is not fragile or newly formed. General relativity has been tested for over a century. Its predictions have been measured in laboratories and observed in the bending of starlight near the sun. Even the satellites that help your phone determine its location must account for the subtle effects of curved space-time to remain accurate. The equations are not abstract poetry. They operate quietly in the background of modern life. There is something comforting in this. The same geometry that guides planets in their orbits guides the ticking of clocks in orbiting satellites. The same curvature that holds oceans in their basins ensures that the ground beneath you will remain beneath you tomorrow. It is also worth noticing how deeply embedded gravity is in the structure of Earth itself. The immense pressure at our planet's core exists because layers of rock press downward under their own weight. Mountains rise because tectonic plates push against one another within a gravitational field. Rivers carve valleys because water flows downhill, always toward lower gravitational potential. Remove gravity, even hypothetically, and the entire architecture of the planet would lose its organizing principle. The air would drift away. The oceans would not know where to rest. The very concept of down would dissolve. But such removal is not merely unlikely. It is inconsistent with the laws that have governed the cosmos since its beginning. For more than 4 billion years, Earth has orbited the Sun with steady patience. Gravitational interactions have shaped galaxies, drawn stars together, and guided comets through silent arcs of ice and dust. There is no record in stone or sediment of gravity pausing for even a heartbeat. The rumour of 7 seconds depends on imagining gravity as something external to the universe, a system that might glitch like software. Yet gravity is not layered on top of reality. It is woven into it. If you find your thoughts growing heavy now, that is all right. Let them settle like sediment in calm water. The mathematics can rest. The metaphors can soften. What remains is simple. The force that keeps you anchored to Earth is not fragile. It is not maintained by secret programs or shielded in underground vaults. It is a fundamental expression of mass and geometry. In the next chapter, we will move from gravity itself to the ripples that travel through it. Gravitational waves, those faint whispers from distant cosmic collisions. We will see what they truly are, how they were detected, and why they cannot undo the steady curvature that holds our world together. For now, allow yourself to feel the quiet certainty of weight. The stone of the planet remains patient beneath your feet. The oceans remain cradled in their basins, and space-time continues its gentle curvature, as reliable as breath in the dark. The curvature of space-time continues its quiet work, bending gently around stone and ocean and air, holding everything in its patient embrace. And yet, as steady as gravity is, it is not entirely still. Like the surface of a vast dark lake, space-time can ripple. Not in ways we feel beneath our feet, not in ways that disturb the weight of our bodies against the Earth, but in faint tremors that travel across the cosmos. These tremors are called gravitational waves. To understand them, we return to the image of curved space-time, the invisible fabric shaped by mass. If a heavy stone rests motionless on our imagined rubber sheet, the depression remains constant. But if that stone begins to move, if two stones circle one another, drawing closer and closer, the sheet does not merely stay bent. It quivers. The curvature shifts, and those shifts travel outward in widening circles. In the universe, the most powerful quivers come from the most extreme objects. Black holes, those regions where mass is compressed so intensely that even light cannot escape. Neutron stars, remnants of exploded suns, dense beyond ordinary imagination. When two such objects orbit each other, they do so in a dance of extraordinary gravity. They spiral inward over time, losing energy not through sound, not through light, but through ripples in space-time itself. These ripples move outward at the speed of light, carrying with them information about the event that created them. They are not gusts of wind. They are not blasts of force. They are changes in geometry, stretching space in one direction while compressing it in another, then reversing over and over as they pass. For a century, these waves were only theoretical, a consequence of Einstein's equations. Even Einstein himself doubted they would ever be detected. The distortions they cause are unimaginably small by the time they reach us, diminished by distance, softened by the vastness between galaxies. And yet, in September of 2015, humanity heard them for the first time. In two quiet facilities separated by thousands of kilometers, instruments waited with extraordinary patience. Long tunnels stretched out in perpendicular lines, 4 kilometers each, forming enormous L-shapes. Inside, laser beams travelled back and forth, measuring the distance between mirrors with astonishing precision. The slightest change, smaller than the width of a proton, could be detected. On that morning a signal arrived. It lasted less than a second. A subtle chirp, rising in frequency and then fading. It had begun 1.3 billion years earlier, when two black holes collided in a distant galaxy. Each black hole had been roughly 30 times the mass of our Sun. As they spiraled together, they released energy equivalent to several suns converted entirely into gravitational radiation. It was, at its source, one of the most violent events imaginable. And yet, by the time its ripples reached Earth, the effect was almost imperceptible. The 4-kilometer arms of the detectors changed length by a fraction so small it defies intuitive understanding. The universe had whispered, and we had listened carefully enough to hear it. There is something profoundly beautiful in that listening. Not dramatic, not explosive, but patient. Decades of engineering, countless calibrations, years of silence, all in service of measuring a distortion smaller than an atom. It is a testament to human curiosity, to the quiet persistence of science. Now consider what this tells us about the rumour we began with. The claim suggested that gravitational waves might intersect at Earth and somehow cancel gravity, switching it off for 7 seconds. But gravitational waves do not behave that way. When two waves pass through the same region of space, they simply superpose. They add together momentarily, then continue onward, unchanged in their identity. It is like ripples on a pond. If you drop two stones into still water, the circles expand. Where they meet, the water rises a little higher for an instant, then falls back, the ripples moving on as if nothing extraordinary had occurred. They do not erase the pond. They do not drain it. They do not flatten the water into stillness. Similarly, gravitational waves are disturbances riding atop the existing curvature of space-time. They do not eliminate the curvature caused by Earth's mass. They do not neutralize gravity. They momentarily stretch and squeeze distances by infinitesimal amounts, then pass beyond. Even the strongest gravitational waves ever detected cause changes so tiny that only exquisitely sensitive instruments could measure them. Your body does not feel them. The oceans do not respond. The stone of the Earth remains unmoved. Another quiet truth emerges here. Gravitational waves cannot be predicted years in advance. They travel at the speed of light. The information they carry arrives at the same moment the waves themselves arrive. There is no early warning, no advance glimpse into their path. To know of a black hole merger before its gravitational waves reach us would require information to travel faster than light, and the structure of space-time does not permit that. This is why the idea of a predicted intersection in the future dissolves under gentle examination. The universe does not send calendar invitations for its most distant collisions. It simply unfolds, and when its ripples arrive, we measure them in real time. It is also worth noting how frequently these waves pass through us. Black holes merge somewhere in the observable universe every few minutes. Neutron stars collide, massive stars collapse. The cosmos is dynamic and restless, and yet, for billions of years, gravitational waves have washed through our solar system without ever disturbing the steady pull that binds us to Earth. We are, in a sense, bathed in them constantly. They pass through your body, through the walls of your home, through the stone beneath your feet. You do not notice because their effect is so vanishingly small. The geometry of space-time flexes by amounts too subtle for human senses to perceive. There is something humbling in this. The universe is filled with immense events, collisions of unimaginable scale, yet their echoes reach us as whispers. The stability of our world is not fragile in the face of distant cataclysms. It is resilient, grounded in the mass of the Earth itself. If your thoughts begin to drift here, that is perfectly fine. You might imagine those ripples travelling silently through darkness, crossing intergalactic space for billions of years before brushing gently against our planet. You might picture the detectors listening in stillness, waiting for the faintest tremor. There is no urgency in this listening, only patience. The rumour of intersecting waves relied on the mystery surrounding gravitational physics. The words sound exotic. Black holes, space-time, waves in the fabric of reality. For many, these concepts hover at the edge of comprehension, half understood and therefore easily reshaped into something more dramatic than they are. But when we sit with them calmly, when we trace their behaviour step by step, the drama softens into clarity. Gravitational waves are real, they're astonishing. They're among the most profound confirmations of Einstein's vision, and they are entirely incapable of undoing the curvature that holds our oceans in place. In our next chapter, we will allow ourselves a brief thought experiment. Not because the scenario is possible, but because imagining it reveals something profound about how deeply gravity shapes every layer of our existence. We will step into the impossible for a moment, then return to the steady ground of reality. For now, rest in the knowledge that the ripples passing through space-time are gentle by the time they reach us. The Earth remains anchored by its mass. The air remains wrapped around the globe, and the vast, dark lake of the universe continues to shimmer softly, its waves too faint to disturb the quiet weight of your body against the night. The ripples have passed, faint and immeasurable, leaving the great curvature of space-time undisturbed. We have seen how gravitational waves travel like whispers across a vast dark ocean, too subtle to unsettle even the smallest stone beneath our feet. And now, gently, we step into imagination, not because the impossible is likely, but because exploring it reveals how deeply gravity shapes everything we know. Let us suppose, just for a moment, that gravity did vanish, not gradually, not as a weakening over centuries, but suddenly, cleanly, as the rumour described, 7 seconds in which the force that binds ocean to basin and foot to floor simply ceases. The first thing to understand is that nothing would float upward in the gentle way balloons rise into air. That image, though dramatic, misunderstands motion. Even now, as you lie still or sit quietly, you are moving. The Earth spins beneath you at hundreds of meters per second, depending on your latitude. It carries you eastward in a great arc. You feel stationary only because everything around you shares that motion. If gravity were to disappear, you would not suddenly stop moving. Inertia would carry you forward in the direction you were already travelling. The Earth, meanwhile, would continue its rotation. Without gravity to hold you against its curved surface, you would move in a straight line while the planet curved away beneath you. It would not feel like rising. It would feel as though the ground had slipped sideways and downward at once. Within the first second, separation would begin. The geometry is complex, but the essence is simple. You and the spinning Earth would no longer share the same path. At the equator, where rotational speed is greatest, the divergence would be dramatic. At the poles, more subtle. but everywhere, the connection between body and planet would loosen. And that is only the beginning. The air itself is held to Earth by gravity. The atmosphere presses gently against your skin because it is bound here, layer upon layer by the planet's mass. Without gravity, those molecules would no longer be tethered. They would continue moving at their thermal speeds, hundreds of meters per second, drifting outward into space. Within moments, the air would thin, pressure would drop, ears would pop as they do in a rapid ascent. Breathing would become difficult, then impossible. Consciousness would fade not from falling, but from absence. The absence of air, the absence of pressure. The oceans too would respond. Water, cohesive and heavy, would no longer rest obediently in its basins. It would lift away, not in smooth sheets, but in vast, billowing masses. Surface tension would pull it into enormous floating forms, shimmering and unstable. Coastlines would vanish into suspended chaos. Rivers would unravel from their beds. Even the stone of the earth would feel the change. Deep within the planet, immense pressures exist because layers of rock press downward under their own weight. Remove that weight, and the internal balance shifts. The crust, thin and brittle compared to the mantle below, would begin to fracture as stresses redistribute. Magma would seek new pathways. The planet would attempt to adjust to a condition it has never known. 7 seconds is brief in human terms, a blink, a held breath. Yet in physical systems, even seconds can initiate cascades. Vehicles in motion would not simply hover. A car travelling along a highway would continue forward, no longer pressed against asphalt. Aircraft would follow ballistic paths determined by their velocities at that instant. Ships would lift with the waters beneath them, then drift in confusion. When gravity returned, as the rumour imagines, it would not restore the world to its previous arrangement like a reset button. Objects would resume acceleration toward the Earth's centre from wherever they had drifted. Some would collide mid-air, some would strike ground or building at angles determined by their inertial paths. Infrastructure would not settle neatly back into place, it would shatter. And yet, even this description underestimates the scale. The rumour suggested tens of millions of casualties, but billions of people are outdoors or near windows or travelling at any given moment. The disruption of air pressure alone would render vast populations unconscious before any fall occurred. Power grids would collapse as generators lost cooling. Water systems would fail as pipes emptied and filled with air. Communication networks would fragment. Civilization depends quietly on gravity. Electrical plants rely on fluids flowing downward. Agriculture relies on roots anchoring into soil. Architecture relies on weight-pressing beams into stability. Remove that constant, even briefly, and the delicate choreography of modern life falters. The thought experiment reveals something essential. Gravity is not merely the reason we do not float away. It is the organising principle of our planet's structure. It holds the atmosphere close enough for breath. It shapes mountains and valleys. It determines the flow of rivers and the circulation of oceans. It governs the pressures that allow Earth's core to remain molten and dynamic. If gravity vanished, the damage would not be confined to 7 seconds. Processes set in motion would continue long after its return. The crust might settle differently. Volcanic activity could increase. The oceans, once lifted and dropped, would surge unpredictably. The planet would not simply resume its former calm, but we must remember why we walk through this imagined landscape, not to alarm and not to dramatize, but to illuminate. The scenario is impossible within the laws that govern our universe. By exploring its consequences, we see how deeply gravity is woven into every layer of existence. There is a quiet comfort in that realization. The same force that curves space-time around Earth ensures that the air remains wrapped around you tonight. The same mass that binds the moon in orbit binds the water in your glass to its container. Gravity is not a fragile overlay. It is a foundational expression of matter itself. If your thoughts grow heavy here, that heaviness is fitting. Gravity is, after all, the reason heaviness exists. Let the idea of drifting continents and rising seas soften into abstraction. Let the impossible remain impossible. In our final chapter, we will step back from imagination and return fully to reassurance. We will reflect on the long stability of the cosmos, on the predictability of eclipses, on the patient reliability of physical law. The date on the calendar will arrive as all dates do, carried forward by the steady rotation of a planet that has never once lost its hold. For now, feel the quiet weight of your body against the earth. The stone beneath you has endured for billions of years. The oceans remain cradled in their basins, and gravity, unseen and unwavering, continues its gentle, constant work. The imagined rupture has dissolved now, like a dream fading with the approach of morning. The oceans have settled back into their basins, though in truth they never left. The air remains wrapped around the earth in its familiar embrace. The stone beneath us has not shifted, and so we return gently to what has always been there. Gravity has not flickered. It has not hesitated. It has continued its quiet work throughout every rumour, every speculation, every anxious scroll through glowing screens in the dark. There is something deeply reassuring about that constancy. For more than 4 billion years, this planet has orbited the Sun with patient reliability. The curvature of space-time around Earth has remained steady enough for mountains to rise and erode, for oceans to form and cradle life, for forests to grow and fall and grow again. The ground beneath you tonight is part of a story that stretches backward through epochs of ice and fire, through asteroid impacts and continental drift, through the slow accumulation of sediment at the bottom of ancient seas. Gravity has been present for all of it. It held the first droplets of water against cooling rock. It guided rivers toward the sea. It kept the atmosphere close enough for lightning to strike and chemistry to unfold. It bound the moon to its orbit, allowing tides to rhythmically stir the shores where life first ventured onto land. When we step back from the rumour that began our journey, what emerges is not fragility, but resilience. The eclipse that lent the story its anchor will still occur. On that August day, the moon will pass between Earth and Sun with quiet precision. The sky will dim, shadows will sharpen. For a few minutes, daylight will resemble dusk, and stars may appear where blue once stretched unbroken. It will be a beautiful alignment, predictable down to the second because celestial mechanics is reliable. Eclipses feel mysterious not because they are unpredictable, but because they remind us that we live within a vast choreography. The moon's orbit is not random. The Earth's rotation is not erratic. Each motion is governed by the same gravitational geometry we have explored together. When the eclipse ends, sunlight will return as it always does. The air will remain where it belongs. The oceans will continue their slow breathing along coastlines. Nothing fundamental will have changed. There is a quiet lesson in this. In an age of rapid information, of headlines that pulse with urgency, of claims that travel faster than reflection, it is easy to feel as though the world itself is unstable. Yet beneath the swirl of narratives and notifications, the physical universe remains remarkably steady. The laws that govern mass and motion do not trend or go viral. They do not bend to rumour. This steadiness is not cold or indifferent. It is the very reason life is possible. You can trust that when you release a cup, it will fall. You can trust that tomorrow will follow tonight because Earth will complete another rotation. You can trust that the sun will rise because orbital mechanics has not failed for billions of years. These are not matters of belief. They are consequences of a geometry that has been tested, measured, and lived within by every organism that has ever existed here. And perhaps that is the deeper comfort. Gravity is not maintained by secrecy. It does not require bunkers or classified budgets. It requires only mass and space-time, both of which are abundant. When conspiracy narratives arise, they often exploit genuine uncertainty. Science does not claim omniscience. There are mysteries still unsolved. Dark matter, dark energy, the precise unification of gravity with quantum mechanics. But uncertainty in some areas does not imply instability in all. The foundation is firm even if the edges are still being explored. If you feel your thoughts slowing now, that is welcome. Let them settle like sediment in calm water. The universe does not demand vigilance from you tonight. It does not require you to brace against catastrophe. Instead, it offers something quieter, continuity. The same gravitational field that held ancient stone beneath prehistoric oceans holds the floor beneath you now. The same curvature that guided comets past the sun guides satellites in orbit above your head. The same mathematics that allowed us to predict the eclipse decades in advance allows engineers to keep spacecraft steady as they cross the void. There is elegance in that consistency. We began with a rumour that suggested sudden rupture, 7 seconds of cosmic failure. We end with a recognition of cosmic patience. The universe is dynamic, yes. Black holes merge, stars explode, galaxies drift and collide. but the local stability that allows life to flourish on this small blue planet is robust. Gravity is not a fragile thread, it is the loom on which the fabric of our world is woven. As August approaches, some may remember the date once associated with unease, and then the day will pass, as days do. The eclipse will darken the sky briefly, then release it back to light. Gravity will remain constant through it all, as indifferent to rumour as stone is to shadow. If you're listening late at night, perhaps the room around you is dim now. Perhaps the weight of your body against mattress or chair feels a little more noticeable. That weight is reassurance. It is evidence of a universe behaving exactly as it should. There will always be new stories, new claims that test our understanding. Some will be creative, some will be persuasive. But knowledge approached with patience provides a steady counterbalance. Not loud, not aggressive, but firm. You do not need to fear the ground slipping away. The Earth has held life for billions of years. It will continue to hold it tomorrow. The oceans will remain in their basins. The air will remain around your lungs. The stars will continue their ancient dance, guided by the same quiet curvature that keeps your feet anchored tonight. And if you find yourself drifting towards sleep, let gravity do what it has always done. Let it hold you gently against the Earth, as reliable as breath, as constant as the turning of the planet beneath the dark. And now we can close the circle gently. Let this final moment feel softer than the rest. The date that once carried tension will arrive like any other day. Morning light will spread slowly across rooftops and fields. The planet will continue its rotation without hesitation. Somewhere, the moon will slide into alignment with the sun, and the sky will dim in that familiar ancient way that once startled our ancestors and now inspires quiet awe. People will step outside to watch. Shadows will sharpen. Birds may pause. The air might cool slightly. For a few minutes, darkness will gather. Not the darkness of catastrophe, but the gentle, predictable shadow of one celestial body passing before another. And then the light will return, steady and warm. Gravity will never have left. The oceans will remain cradled in their basins, rising and falling in their patient rhythm. The mountains will stand as they have stood for ages. The atmosphere will continue to wrap the Earth in its invisible embrace, thin but sufficient, delicate but enduring. The universe does not flicker with rumour. It moves with patience. Perhaps that is the deeper lesson of this journey. In a world where information travels instantly and fear can spread in seconds, the laws of physics remain unhurried. They do not respond to speculation. They do not bend to trending narratives. They persist, and there is comfort in that persistence. When the mind drifts toward worry, toward imagined collapses and hidden programs and secret countdowns, it can return to something simpler: the weight of your body against the Earth, the steady pull beneath your feet, the knowledge that gravity has held this planet together for billions of years without interruption. It will continue. If you have listened this far, perhaps your thoughts are quieter now than when we began. Perhaps the edges of the rumour have softened into curiosity, and curiosity into calm. That is enough. Understanding does not need to be loud to be powerful. It only needs to be steady. And so, as we close, let yourself rest in that steadiness. The ground is not slipping away. The sky is not preparing to unravel. The cosmos is vast and sometimes dramatic. Yes, but here, on this small world of water and stone, the forces that shape our days are dependable. Thank you for taking this slow journey through uncertainty and into clarity. If you found comfort or fascination here, you are warmly invited to stay connected. You can support this quiet exploration of science and mystery by subscribing, by sharing, by offering a small signal that these calm investigations matter to you. Your support helps these thoughtful journeys continue. Stories told not to alarm but to illuminate, not to overwhelm but to gently unfold. There will always be new myths, new cosmic questions, new intersections between imagination and reality. And we will meet them the same way, patiently, curiously, anchored in knowledge rather than fear. For now, though, let the room grow quieter. Let gravity do what it has always done. Let the Earth turn beneath the dark. And wherever you are listening from, may the steady weight of the world bring you comfort. Good night.